climate change has increased the overall temperature of the atmosphere and water. What's that mean other than it getting warmer? Well, it means that there's more energy in the atmosphere. And so storms have more velocity and the winds have more punch as a result. Because it's warmer, more water can evaporate into the atmosphere. So there's more water that can come down faster. Like, look at what just happened in Texas, like a foot of water in an hour. It's crazy. And that's going to be happening more and more. So it's like, okay, well, how do we design cities? Well, interestingly, one of the best examples of how you would design a city to deal with these things is traditional Europe, like from the Middle Ages through the Renaissance up to the mid-19th century. Those buildings were built of stone, thick, like they were built 6, 7 stories tall at max. No matter what storm you throw at it, it won't have an impact.
Hello and welcome to the Conspiracy of Goodness podcast. I'm your host, Dr. Linda Ulrich, and I'm also founder of the mothership website of this podcast called The Goodness Exchange. There you're going to find, thousands of articles that we've written about what's right with the world. There is an enormous wave of goodness and progress well underway in the world, and the problem is we're just not hearing enough about it. The Goodness Exchange and the folks that we interview on this podcast will revolutionize your worldview. If you visit regularly, you're going to meet people like our guest today, and you're going to go, what? And see that this world and the future is bright, and there are plenty of people holding a lantern for things, and it's going to be okay. Maybe it's just 2 steps forward, 1 step backwards, but people like our guest today, Craig Applegath, are in that 2 steps forward, leading us down a path to super, super cool futures. Today, we're going to shift our perspective upward and outward, even decades into the future with Craig. He's someone that can help us kind of reimagine what's possible for our whole entire planet. He's an award-winning architect, a visionary urban designer, and one of the most forward-thinking voices in this whole regenerative city planning movement. Now, you might hear city planning and think, oh, this is not for me. Stay with us, folks. Craig has this amazing way of making you think that anything's possible. He's not just designing buildings, he's designing futures for us all, and futures where systems are like beautifully interconnected and beautifully resilient. And for decades, Craig's been at this. He's been asking bold questions like, what if cities could act like an ecosystem? What if the architecture could respond to climate change, not just by minimizing the harm, but by healing? That's a fascinating subject we're going to talk about. And what would it take to build neighborhoods that are regenerative instead of extractive? So today you're going to hear answers to those questions and probably be able to ask some big ones of your own. Craig is the founding principal of, just so you have a little background on Craig, he's the founding principal of Dialogue's Toronto studio. And we'll let him talk just a little bit more about what that means. But this is a huge architecture firm that has everything to do with all the components of architecture. And again, I'm going to let him go into that. But here's the deal. Craig is a visionary person that brings interdisciplinary teams together to tackle super wicked problems. And I want him to explain how that's different than wicked problems. So welcome, Craig Applegath.
Linda, thank you so much. It's such a pleasure to be part of this podcast. I'm not sure I'm going to live up to your really, really lovely introduction. Thank you very much.
Oh, you are. We've got our questions.
Okay. I'm going to try, but I typically find myself struggling with all of those challenges, making a few inroads and coming up with some interesting ideas and designs and working with my team. But it sounds very, very heroic. So I don't see myself as much of a hero. I see myself more as very curious and always interested in things just over the horizon. And so that's when you say looking 10 or 20 years, I think I was just born with this curiosity to say, like, well, it's fine, but what about in 10 years? And what about in 20 years? So that's the sort of
and that seems to be a thread. That's a thread through almost all the innovators that I interview. So
but you asked me a question, I didn't answer it.
Okay, so
the question was,
this is super
wicked problem.
Okay, let's start there.
Okay, so first of all, we'll back up to a wicked problem. This is actually a definition that sociologists and scientists have been using for some years. You can go to Wikipedia and look it up. But a wicked problem is a problem with many, many variables that are interacting with one another. So if you solve one of the variables, it may actually cause more problems with another variable. So it's a very, very difficult problem with a lot of moving parts, and it's very difficult to solve. So it's wicked. Super wicked problem is a wicked problem where the person or the group trying to solve the problem is actually causing the problem. That would be climate change, right? So climate change is a super wicked problem. And I've seen most of my work over the last 20 years wrestling with the super wicked problem of climate change and what kind of difference can we make as a species.
Because we're causing it. So,
Yeah.
so not only are there all those interactive parts, but you gotta turn the mirror on ourselves.
And that's one of the most difficult things to do. And I think one of the most difficult things is another sort of definitional problem is willful blindness. The idea is that we, through evolution, have really evolved to have this problem of being blind to many things that are right in front of us. We sort of deny them because it makes our existence easier than if we embrace all the complexity of the world. So that willful blindness to our reality is something that's allowed us to succeed in the past. But being willfully blind to climate change is going to be a real and is now a terrible challenge because we've gone beyond the point where we can prevent it. Now it's a question of how much can we dial it back, and we also now have to figure out how to adapt to it. So that notion of willful blindness is a really challenging one.
When we had our pre-call, I wasn't really sure urban design, architecture was something that we, that just demonstrated it was still an amazing world. And you quickly changed my whole entire view of the subject when you gave me this rundown of how we've been designing buildings in the last maybe century compared to how people by necessity built buildings 1,000 years ago. Because there are plenty of buildings that are 1,000 or more years old that, are resilient in storms. They survive heat incidences, on and on. But not many, if any, that are built to last 1,000 years now. So please give us 5 minutes, 6 minutes rundown of this whole predictability of the problems with modern and current design and buildings compared to where we were at when we used materials that could stand the test of time.
Why don't we first paint a picture of what the next 50 years is going to look like in terms of the kind of challenges that our cities and our buildings in those cities are going to face.
Okay.
And how will we adapt to that new reality?
And this is not doom and gloom. It's just
this is not
reality.
Doom and gloom. I mean, this is reality. This is not. This is not a sort of a scare tactic like this is going to happen, so we have to deal with climate change. Well, that's pretty clear. Over the last 20 years, I always find myself about 10 years ahead of the curve, and therefore sort of not in sync with the current trends and what is being designed. Because if you're thinking ahead a bit, people aren't always there. But I can remember 15 years ago starting to think about resilience and adaptation because I started to see the potential of what climate change would do to buildings after you see some floods or some storms. You say, well, if this is going to become more regular, how are we going to adapt? And yet at the time, it was sort of politically incorrect to be talking about adaptation because it might be considered a moral danger for that discussion because it would take the emphasis off of climate mitigation. In other words, cutting back on CO2 emissions. So it's like, yeah, but I'm a scientist by training. Like, just because it's not, you're worried about it doesn't mean it doesn't exist. So started looking at those issues, and you start to realize that some of the big, huge challenges we're going to face are heat events, severe heat events that will cause mortality. So that typically means that temperatures above in Celsius 30 degrees, I guess in Fahrenheit 100 degrees, and 100% humidity. And that means the body, when it sweats, the sweat doesn't cool the body. And so people expire if they're in that condition without being able to be cooled for too long, like after a number of hours. And so that's one thing that's going to be happening more and more. Heat events, severe heat events. The other thing that will be happening is severe storm events. So more frequent hurricanes, tornadoes, windstorms, because climate change has increased the overall temperature of the atmosphere and water. What's that mean other than it getting warmer? Well, it means that there's more energy in the atmosphere. And so storms have more velocity and the winds have more punch as a result. And the rain, and there's more, and because it's warmer, more water can evaporate into the atmosphere. So there's more water that can come down faster. Like, look at what just happened in Texas. Like a foot of water in an hour, right? So it's crazy. And that's going to be happening more and more. So it's like, okay, well, you can say that's terrible. We shouldn't have done that. Yeah, well, that's not helpful. So how do we design cities? Well, interestingly, one of the best examples of how you would design a city to deal with these things is Europe right now, or traditional Europe, like from the Middle Ages through the Renaissance up to the mid-19th century, before they were building with steel. Because those buildings were built of stone, thick, like they were built 6-7 stories tall at max, and the stone walls were maybe 3, 4, 5 feet thick. And so no matter what storm you throw at it, it won't have an impact. And then the windows were made of wood and some very, very thin glass. And guess what? They'd be broken. But you get your local carpenter that literally lived down the street, could walk over to your house, putty in some new glass, or do a bit of case making and do a new window. So you had this resilience that was built into the system. They didn't think about it that way, but that's just the nature. And then heat events. Well, thick stone is a thermal flywheel. So you have a few days where it gets really, really hot. Well, you go inside and shut the windows and pull the curtains, and the stone absorbs that heat. Now, if it goes on and on for months and months and months, it doesn't work. But typically the heat events don't last longer than a week, 2 weeks. And so that way you've got a building fabric that just by its design gives you some resilience. And then add another thing. One of the things that we're going to be seeing more of is, like Texas, you had all this water come down in a very short period of time. So it doesn't matter whether you're in low area or high area, there's going to be flooding, overland flooding. Well, what do you do for buildings? Well, right now our buildings are built out of, typically on the ground floor, there's a concrete floor and then some floor treatment and then drywall, right? Well, drywall, when it gets wet, you know what it is? It's a mold factory. You can't wet drywall without it creating toxic mold. So look at Europe, stone. Well, no, you get the ground floor wet and you sweep it out and the stone gets a bit wet. And by the way, plaster in the interior of those buildings were plastered. And plaster is antimicrobial. It kills bacteria and mold. So it gets a bit wet, it gets a little bit stained, but it doesn't matter. And you just sweep it out and you start again. So, it's terribly ironic that we think of ourselves as living in a modern contemporary society with all these high-tech features for our building. But when it's attacked by these kind of conditions, it's not resilient. And then you imagine in Toronto, there's a lot of condominiums being built, and they're very well put together. They're very well constructed. However, they're constructed with the idea that they're existing in a climate that existed previous to now, not going forward. So imagine a big heat event happening in a city like Toronto or Chicago. Well, or New York. Well, what happens is our grids are frail now. Like they're at the end of life's end. They're end of life for most of the power grids. So what happens is you get a heat event and everyone turns on their air conditioner all at once, right? Of course they do. And all the transformers get hot and they're hot anyway, and they explode or they go down, or the wires and the high tension wires dip, and then short out. So you get areas of no electricity, and it may take days. Well, imagine being in one of those beautiful condos. They have operable windows, but there's no cross ventilation. There's no elevator unless they've got a generator on top of the building, and it's got a limited lifespan of fuel. And if it's gas powered, the gas mains and pumps may go down too. So you're stuck. You can't get up and down that 20 floors. So imagine if you're an elderly person, you can't walk up and down 20 floors every day. There's no water for cooking. There's no water for toilets, because the water in a 7-story building is main pressure. Like the pressure from the mains will drive the water up that far. No, in a big building, you need pumps. The pumps stop. No water, no cooling, no air, and your heat. You're in an oven. So we've designed ourselves buildings that are not good for severe heat events. Okay, flip it onto a severe storm event. You know, Linda, this podcast is supposed to be about good news. This does not sound very good news to me. But anyway.
I was going to pause just for a minute to remind people that we're going to get there.
We're going to get to the good news. Really. And so, or you're just going to turn this off. Anyway,
no. I think you've got to do that. I think you've got to make us aware, because I remember these parts of our conversation vividly, like it was yesterday, because Craig already went through this. Keep going.
Okay. So all these really high quality windows in high-end condominiums and rental apartments, whatever, they're made of aluminum, curtain wall, beautiful, or window wall. Big storm comes through, breaks them. Well, they can be repaired, but they're made in some other state or province, or they're made in China or Taiwan. And so because a whole city's been bashed up, how long do you think it's going to take to get those windows repaired? And what happens if it's a storm in the winter? And so you've got this, there's nothing wrong with the construction of our buildings, but they're not conceived of for the future. And this is a real challenge. And whereas take your European 19th century building that most architects would now turn up their nose at as being, antiquated and old technology. The storm comes through, breaks the windows, and as I mentioned before, you get a bit of glass and putty them in. And then if the heat event happens and the electricity goes out, okay, well, you've got cross ventilation. You open the windows, you walk up and down the stairs. The water pressure is coming up because it's gravity fed from some big tank somewhere. They didn't have electric power then. So you just have a heat event. And then if it's a heat event, you go inside. If it's a storm event, you just repair. And if it's a flooding event, well, you wait, and like Valencia, Spain, you go back there now, you'd probably see nothing of any consequence. So we certainly have the technology to deal with adaptation. But even more exciting, I think, is that we have the technology and the economic logic to pull back on causing climate change. So there's a really good book, and I've got a couple books here, and I'm going to hold one up. This one here, called Electrify. This is a must read. This is by Saul Griffith. I read this a few years ago. And in fact, I think he was interviewed on Ezra Klein's podcast, and then Ezra Klein came out with this book that's just come out called Abundance. It's a really good book. But basically, the logic behind electrify is that if we are going to pull back on carbon emissions, what we're going to have to do is get off of using fossil fuels. And it's not going to be a punishment to do so. In fact, it will allow a huge stimulation of our economy because all our grids need to be repaired and replaced anyway. So just create smart grids. And electricity can come from hydro, which is zero carbon. It can come from nuclear, which is zero carbon. It can come from solar photovoltaics, which is zero carbon. And it can come from wind. And all of those, well, with the exception, debatably, of the nuclear, but all of those are less costly per watt or per joule of energy than fossil fuels. So there's no economic argument for using fossil fuels. What there is lock-in, and there's contracts, and there's political, requirements for it, let us say. And so I think the electrification process will allow us to zero our carbon. Houses go from using oil or using natural gas to using electricity and heat pumps. That's not hard. You go from using natural gas for stoves, some people still do that, to using induction. All of that uses, the whole of that process uses less energy because to make all that fossil fuel produces a huge amount of heat. Like to generate electricity from fossil fuels creates a lot of waste heat, whereas to generate electricity is much from wind and from solar and stuff is much less waste of energy. So long story short, we have to electrify. So on the pulling back, mitigating, electrification, the most important thing we can do. And it's also going to create a whole whack of jobs too, right? I mean, if we can get over the current politics of it right now, it will be a boom and a boom. So I think we have, the good news is, and this is a good news podcast, we have all the technology. And all the technology is less expensive than the technology we're using now, fossil fuels. It doesn't cost more. It will require investment, but the investment still has to be made because right now all of our infrastructure is nearing the end of its life. It's going to have to be switched out anyway.
This nearing the end of its life thing, that is another concept that I've lived abroad. My husband and I are Irish citizens. We've lived in Italy. We've lived in Spain. That's another concept you dropped on me right before everything you just said about storms and heat events and so forth. There are buildings that were built 1,000 to 2,000 years ago in Europe that are just still sitting there like the day they were built.
Yeah.
Now, there are no modern buildings that are going to last 1,000 years. Are there, Craig?
No. Well, I won't say no. There may be someone that's designed one, but I will say that the technology we use is not designed to last a long time. It's designed to last the length of the mortgage and investment. The buildings that were designed pre-modern technology were designed or were built with techniques that were as old as mankind. Basically, bricks and mortar or stone and mortar, or just stone without mortar. But still, all of those things have been honed skills, and there were groups of there were guilds that taught younger men, typically, how to do that. So there was a culture of building that could build stone buildings and brick buildings. And if there was a bit of damage, they were easily repaired. Everyone knew how to do it. There was no heavy machinery required. They weren't that tall. Everything was human labor. It was slower. It was a different economy. Right now, our buildings are built of steel and concrete, mostly. Now, one of the things that I'm exploring and advocating is mass timber, but we can talk about that in a little bit. But here's the problem with concrete right now. The concrete we use does not last forever. And in order to make concrete have the strength, not the strength, but the ability to bear load, it has to have reinforcing steel in it. And that reinforcing steel in it over time, it's pretty good for 20, 30, 40, 50 years. But over time, that steel, the moisture in the concrete seeps in and it starts to oxidize, corrode. And then when steel rusts, oxidizes, it expands. And that expansion forces the concrete to ball and break. And so you see this with bridges when they're having to repair concrete bridges. They're like, big chunks are falling off. What's happening there? It's because the reinforcing steel in it is starting to expand because of oxidization. And so all of the buildings we have that are designed with concrete, unlike the Roman concrete that didn't have the steel in it, will have a limited lifespan. And then all of the other component parts, like, for example, the window wall systems, the curtain wall systems, they're composed of hundreds and hundreds of pieces. And the pieces are connected together with different kinds of materials. For example, there may be rubber, or there may be silicone, or there may be some sort of plastic. And those connection joints and so forth, who knows how long they're going to last? How long are the seals going to last? Well, when you put a sealed window unit, they're like double paned glass, everyone has it in their homes and buildings. There's a little piece of metal around that to hold the piece of the glass apart, and they're sealed and they suck the air out of it. Well, those seals over 10 years break. And you can tell because of condensation all over the place. Well, it's 10 years and you have to replace it, right?
And so imagine. And it's not just calling a carpenter who probably lives in the same building.
Well, it's because, if you have a wood window, you could probably do it. But otherwise, it's a whole window. You have to, you take it apart anyway. So we are not designing for longevity. We have become the world over basically a throwaway society. You just chuck it, get a new one. And so I think that's another issue altogether. But the resilience to climate change, the impacts of climate change, all of a sudden is starting to have some impact on this issue, because you can't assume that the climate's going to be benign anymore. You're going to have to assume that the risk of danger happening is going up. And you may, as an individual, not want to believe it, but you know who believes it? Insurance companies. Do you know there are states right now in the United States that are having their ability to insure their houses taken away from them? And so people can't get mortgages except through the state and federal mortgage. But the private insurance companies are going, we're out of here, because it's too dangerous. Like we can't make any money because there's too many incidents of storm water or hurricanes or whatever. So they're like, no.
All right. I want to take a step back here because you and I talked a little bit of philosophy when we first met for our pre-call. And I think these are some fairly important little concepts to throw in here after we've really looked at the big picture of where we're at. You mentioned, and I love it, the starfish story. Because this is really where we're at. Tell the starfish story as you remember it.
The starfish story is a story about hope, and it's also a story that is very relevant to our time, not just with climate change, but I think with a lot of challenges we see in the world today. And the story goes like this. Imagine it's very early in the morning. It's a California beach. So there's a bit of fog and mist coming off the ocean onto the beach. And there's a fellow, and he's walking down the beach, and down, further down the beach, he can see another guy picking up stones or seashells or something and throwing them into the ocean. He reaches down, picks up another one, throws it in the ocean. But as he gets closer, he realizes that the person throwing is not throwing stones, he's throwing starfish. And as he looks around the beach, there's thousands of starfish that have been left high and dry by the high tides receded and left all these starfish on the beach. And they can't get back. They can't walk back to the water. And so this person is bending over and picking up starfish and throwing them in the ocean. so that they don't dry out, because the sun's going to come out in an hour or so and just dry them all out, kill them. And so the first guy says to the guy throwing starfish, "What are you doing?" And he said, "Well, I'm picking up these starfish and throwing them back into the water because otherwise they're going to die. They're going to get cooked by the sun." And the first guy says, "Well, but look, there's thousands and thousands of starfish all over the beach. Throwing one or two starfish in is not going to make any difference whatsoever. Why are you doing this?" The second guy reaches down, picks up a starfish, and throws it into the ocean and said, "Well, it made a difference for that one." And I think I get emotional when I tell the story, because I think that story is about where we are right now. And your podcast is a good example of someone throwing starfish into the ocean. Someone might say, well, you can have these wonderful people talking about good news, but the world is filled with terrible news. What good is it going to do? Yes, but what about that podcast that moves someone to do something that's really important and wouldn't have otherwise done so? There's a ripple effect. And I think for all of us that are in the business of wrestling with these super wicked problems, I don't think any of us think we're going to solve the big picture, but we do have some hope that maybe we'll be able to solve some piece of it, and that others may be inspired by it and do something with that knowledge or with that insight or with that motivation. And so that starfish story just sticks with me, because I'll tell you, it can get pretty damn depressing when you're working on some of these issues, when you see what's ahead. But you have to think, no, you're going to design that prototype or do this or mentor this student that's really charged up about doing something with respect to climate change, and there'll be a ripple effect. And that's why I love the story.
It's beautiful. And it's so fitting for what we want to, dive deeper into with the rest of this conversation. Okay, so we're going to take a break, and we come back, we're going to hear about solutions, because that's really what Craig is. He's what one of our podcast guests calls a solutionary.
Oh, that's a cool term.
It's a cool term.
I'm going to write that down here.
Yes, solutionary. Okay, and I'm going to, there's something called the solutionary way. And I am going to share the episode we did with a wonderful innovator in education named Zoe Weil. She teaches people the solutionary way. Okay, so let's take a break. You know how the constant negative noise in our digital lives feels like it's reaching a boiling point? Now, many of us have tuned out the news and social media almost entirely. Well, it doesn't have to be that way. There are newsworthy stories about amazing progress, innovation, leaps in human potential, and wonders in the natural world, and they're just not reaching the top of our feeds. We can have access to this, but none of us has the time or maybe even the emotional stamina to search through all the doom and gloom news to find what's right with the world. Okay, enter the Goodness Exchange. There, we are giving instant access to positive news for curious people. Did you hear about the recent Harvard study that found that exposure to just 4 minutes of good news can make you 32% less anxious and 18% more optimistic? Well, I don't know about you, but I need those kind of numbers in my life. So if you want to live with more joy and way less fear, it's really simple. First, you join us at the Goodness Exchange. Everyone around the world has the opportunity to access this kind of content. And we've promised no politics for about a decade, so you're safe from all that distraction as well. Second, you allow this new, more positive, balanced worldview to put a spring in your step again. It can change the way you react to your kids, your coworkers, everybody you come in contact with. And the stories we write about can make you the idea person in your circles. These challenging times call for us to wake up and take control of our perspective. The people who use the Goodness Exchange have the ability to react to the harshness of the world much different because they know way more about what's right with the world. And that's a resource. So, subscribe to The Goodness Exchange, our YouTube channel and the podcast, and use this content to live a more expansive worldview. It is still an amazing world out there, and you can be a part of it. Welcome to the Conspiracy of Goodness. Okay, we're back with architect and futurist designer Craig Applegath. Craig is a person who's leading us into a future that is more resilient, more sustainable, and I would like to say that you're even going past the, reacting to climate change stage. You're trying to get us to do more about healing the planet and, living in a way that is regenerative. So I am so excited about having you explain. Let's go a little deeper now in the second part of the conversation so that we understand some really key, important concepts, things that I'm sure people will hear about, but probably haven't heard about yet. I want you to talk to us about mass timber innovations and embodied versus operational carbon.
Okay, so let's just flip that around in order, because I think understanding about operational and embodied carbon will help cast some understanding on the mass timber and why it's important.
Okay.
So since the 70s, America, Canada, Europe, much of the world's been focused on energy conservation, saving energy. And it came out of the 70s because of the oil crisis at the time. And there was going to be a challenge for enough petroleum to be provided for us in North America, so because of what was going on in the Middle East. So we had to save energy. So it wasn't about carbon. It was about saving energy. So as the whole topic of climate change began to emerge, it got grafted on top of this notion of saving energy. Energy is really a proxy for carbon. It's not energy that's the problem. It's that generating energy, like electricity through natural gas or coal, even worse, produces carbon dioxide. Using gasoline in transportation or diesel fuel in transportation is energy for those vehicles, but it also produces carbon. So it's not the cost of it or where you get it. It's the fact that CO2 and methane, for that matter, is being emitted into the atmosphere, causing climate change. Okay, so that is all about the notion of making our homes and our buildings and our offices and retail and all that stuff more energy efficient. That is an operational carbon conversation, meaning when you operate the buildings, it uses energy, which releases carbon. That's operational carbon. And that's what we've been focused on since climate change got going as a discussion in 2001-ish is when it became formalized, when the USGBC was formed, basically. That became a public thing. But as we have become more effective in reducing our operational carbon by highly insulating our buildings, it's becoming apparent that that's not the only carbon we better be thinking about. There's what's called embodied carbon. And that's a fancy term for all of the carbon dioxide released into the atmosphere in the manufacturing of the products to build buildings or build highways or do anything else. So that if you want to do a building right now, you have to dig gravel out of the earth and you have to then fire up the kilns to make cement. And you have to then move it and cut it and form it. And then you have to, heat the forges for the steel. All that energy used releases CO2 in the atmosphere. That is embodied. So when you bring a steel member to the site to erect it as your steel structure, or when you bring concrete and pour concrete at the site, all of that stuff has in it, not in the material, the CO2, but in creating it, you have released CO2. And that's called embodied. It's not really embodied in the material. Like some people get the idea, well, the CO2 is in the material. No. It's not the CO2 in the material. The CO2 released by the harvesting, manufacturing, transportation, construction of that. Now, here's the interesting thing. As we become more effective in reducing operational carbon, what do? Well, we make buildings that are more insulated. And where does the insulation come from? Well, you have to get more and more of it, and it's got embodied carbon. And the embodied carbon often, like, think of the polyurethane insulations. I won't name any. They're just filled. I think the whole process releases tons of carbon. And so it's like, oh dear. And all the heat to make fiberglass insulation. So it's like, wait a minute. We better be careful that in reducing our operational carbon, we're not actually releasing more carbon into the atmosphere by trying to reduce our operational carbon. So now, like we have in our architecture and engineering firm, we have people that do the analysis, the life cycle carbon analysis. And there's two curves. There's the operational carbon curve, and then there's the embodied carbon. And you have to balance. And you're like, we don't want to insulate the building as much as it can be, because the energy and the carbon that are saved is not actually going to be as much as the extra insulation will release. So now the discussion is embodied and operational.
Okay. And I think I just want to pause here. I think this is really, really important for every single person on this planet to understand. That should be like taught in the 3rd grade. Because it is so fundamental to the choices we make in societies. You know, I'm for the Midwestern United States, where I grew up in central Illinois. All you can see is corn as far as the eye can see. And, you know, there's the whole ethanol, the production of ethanol from corn to supplement the oil the gas we put in our cars. But the ethanol, producing ethanol from corn produces so much carbon dioxide. And
the embodied energy to grow the corn, right? All the tractors and the fertilizer, all that stuff.
Yes. Yeah. And we didn't ask ourselves any of those questions before we literally leapt into all those systems. And now they're so foundationally in place in the Midwest. Right. You're like a heretic if you talk against it. So I really want to just
Willful
make sure
blindness, enters the picture again.
Yes. I think we've got to have some serious critical thinking. Okay, carry on.
Okay, so where does mass timber fit in?
Okay.
Well, first of all, I'll have to explain what mass timber is. You once said that you live in a log or timber,
a super insulated log home in Vermont. Yeah,
but the logs are solid, aren't they?
Yes.
Right. They're made, what are they made from? Douglas fir, or are they made from Douglas fir? Duck fir. Yeah, okay. Yep. So that is traditional timber construction. That's been around for hundreds and hundreds and hundreds and hundreds of years, right? Mass timber is a really interesting innovation where you take smaller pieces of timber, like imagine 2x4s or 2x2s. And these are made from pieces of wood like that you wouldn't otherwise be able to use in construction. And you take small pieces and you glue them together. So you can make a column or a beam made from 2x2s or 2x4s glued together, pieces 4 or 5 feet long, but they're glued with super strong glue that bind these together and make mass timber from small pieces. And why this is effective is because if you make mass timber from sustainably harvested forests, then you are reducing the embodied carbon by somewhere between 13 and 25%. It depends on who you ask and what forest it is. It's just less energy and carbon intensive. And wait, there's one more thing too. And this is now, I won't say controversial, but it's argued as to whether or not it should be counted. And that is the stored carbon in wood, because wood stores CO2. I'll give you an example. I love this number. 1 cubic meter of wood. So That's close to 1 cubic yard, just a little more than 1 cubic yard of wood, stores in the cellulose 1 metric ton of carbon dioxide. That is storing it from falling in the forest and rotting and releasing methane and carbon dioxide. So you can store carbon by building with wood. Now, it's not counted because a lot of the critics say, yes, but your building may only last 25 years and that wood could be disposed of and then released. Like, wait a minute. A really great mass timber building, you wouldn't destroy the wood. You take the wood and you do something else with it. But that's another, we won't go down that rabbit hole.
Exactly.
Right. But nevertheless, you've got reduced embodied carbon with mass timber and the potential to lock up and store carbon. You've got one more thing that's really cool about mass timber. Biophilia. And that is the human brain responds to natural environments. Like when you walk into a forest, your brain releases hormones that make you feel good. And when you walk into a mass timber building, the wood around you does the same thing. So it's just beautiful. You know, funnily enough, we're doing a number of mass timber buildings here. That's my specialty, and working on a Centennial College's mass timber building, 6-story mass timber building. I noticed every time I went to site when it's being constructed, it was clean, and the people working there, it was like they were at church. They were quiet. There was sort of a reverence. It smelled beautiful. They were taking care of it. Usual construction sites are a mess. They're covered with coffee cups and junk, and it stinks of concrete and steel because steel is oily. And there's nothing wrong with that, but it doesn't smell good. It smells dangerous, right?
Yes.
Everywhere on steel smells dangerous. But wood, as you go, oh, and you just sort of get quiet and you're like, oh, this is really nice. Yeah. So I think that has tremendous
That's not
power.
Nothing.
No, it's not nothing.
Something. It's so important.
Imagine as a kid growing up in a school that's made of mass timber or a log as opposed to a drywall or concrete block. I went to high school in a place that when I look back on it was like a factory prison. It wasn't. But it was. I loved the high school and the teachers were amazing. But the design of it was like, it could have been a factory, right? Modernism with painted concrete block.
I got to tell you, most Canadians don't, but almost everybody else asks me if my background is real. There's something about all this wood behind me. Now the ceilings are wood, everything's wood because we live in a timber frame house and everything, ceiling, floors, everything's wood. But people, there's something that makes us smile when they see this background and they think it's fake.
Well,
and it's wood.
They make smile because it's fake, or they smile because they like the wood.
It's the wood, but they're so used to seeing sterility. They're so used to seeing plastic fantastic that it's refreshing, right? Yeah. It's refreshing. I think that last point you made is really important to how we go forward too. Is how things make us feel.
And it's nice to have solutions to these super wicked problems or pieces of super wicked problems that don't feel punishing or that we've stepped down. I think between mass timber and electrification, we step up into a world that's much more humane and much more like engaged with our senses and who we want to be as creatures. If you look at suburbs now across the world, not just North America, they're just crap. They're plastic, neon, just horrible. They all look the same. There's no place to go. There's no place to be. They're placeless. And part of it's the materiality. Have you been in any little village in Europe, no matter how poor it is, that you don't go, this is lovely. Like, look at this. And the locals are like, this is terrible. We don't have this. We don't have this. Like, no. I can just hang out here and have a coffee. No, there's the materiality of our environment has huge impact on our psychology and our well-being.
So all this kind of comes into a topic that I think makes the hair stand up on the back of people's necks sometimes, which is prefabrication and modular design. Because I'm sure the use of mass timber and this thinking about how we tease things apart with embodied versus operational carbon, like, doesn't the natural thing kind of lead us to prefab and modular design as being a good thing?
The answer is yes. And I think one of the challenges, aside from the technical and economic challenges, is people's perception. When you hear prefabrication, modular, they think, is that for public housing? Is that really something I'd want to be in? Is that cheap? Is it plastic? Is it trailer park? Is it going to blow away? All those kind of negative connotations when you hear those words, that's one of the challenges. But I think one of the opportunities that prefabrication allows for is precision and speed and economy of scale, but only if you have market demand that can keep a factory going. And we were talking earlier about this book, Abundance. This is by Ezra Klein and Derek Thompson. It's a wonderful exploration at the beginning of the book of how, since the 70s, we've set up so many regimes for making sure that we do no harm to the environment and provide for effective planning, that it's almost impossible to do housing quickly. And so you, as a developer, you can take 2, 3, 4, 5 years to get your development approved. Well, if that's the case, you can't manufacture at speed and at scale thousands of units and put them up quickly. And because the planning approvals process is just so prohibitive in terms of time. So I think the question is not, can we do it? It's, we've set our planning and regulation up, environmental regulations, zoning regulations, up so that it prohibits the effective rollout of housing. And we have a housing crisis in North America. We have a housing affordability crisis, and we have a housing supply crisis. And yet, we have all these challenges that were created to prevent us from the challenges of industrialization and development after the Second World War, because, there was pollution and there was noise and there was degradation of environments and so forth. So all of these things are really, really effective at stopping that. But they're also really effective tools when people don't want any more housing in their neighborhood. So the answer is yes. It's a very good way to produce housing, and you can make it out of mass timber. And mass timber is something that's made in the factory. Mass timber is very precise, like to the millimeter accuracy. And so there's 2 types of modular, Linda. One is volumetric, and that is where you build the unit. It's a completely built unit. It's got its walls, it's got all the equipment inside and so forth. And then you stack them on each other like Lego, right? So each unit is like a Lego block. And the other is modular parts. So there's walls, there's floors, there's stairs, there's component parts that are flat packed, and you take them out and you put them together on site very quickly. So the ground floor of concrete goes up, and then you have the walls that are cross-laminated timber, CLT, possibly some glue lam beams and columns, and then the next floor goes on, boom, boom, boom. Like in a few days, it's all up, fast, fast, fast. And that is very effective. And then what you've got inside is this beautiful units where, depending on the location, certain amount of it can be exposed. There's issues with respect to flame spread, arguably. That's another question that we could go down a rabbit hole, sort of fun rabbit hole to go down. But nevertheless, they're beautiful to be in, and they're very cost effective. But they're not cost effective if you're not doing a lot of them. So that's the challenge. We have created regulatory requirements that don't allow us to build at scale. But we have all the tools we need to do so. And I think the mass timber, I think the thing that scares people about mass timber that they don't know about it is it's wood and it could burn and it's dangerous. Well, you have lived in a house with a real fireplace, right?
Yeah. Yeah.
When you want to burn a log, you don't just put a match under a log, do you?
No.
No. You've got to have newspapers and then lots of kindling, all the condition and the right draft. And then even then, it doesn't always work, right?
Right.
It's almost impossible to get a log burning unless you have stuff burning under it. So the other interesting thing is wood is something that burns very, very slowly and then chars. And then the char is an insulator against further burning happening. So when we design mass timber buildings, there is a safety factor of the thickness of the wood that allows fire to char it, and then it doesn't burn anymore. So that you are using wood as a fire insulation, a fire retardant. In fact, we will use wood to fireproof steel, because steel will bend and deform when it gets hot. So you have to cover it in drywall, or you can cover it in thickness of wood. So wood is actually quite safe. The challenge with wood, as you know, is water, because wood doesn't like water. When it gets its feet wet, it gets mold and all that kind of stuff. But you can prevent that. That's just like good design.
Okay. So we've kind of hit some major stones in the river here, concepts. But I want to get to this designing for climate adaptation. Like, big picture, what do we do and what do we not do? And I know that one of your big expertise is in prototyping. And in fact, your firm just lets you kind of run wild in prototyping.
Well, I wouldn't say run wild, but
well,
they if I give them a good budget, we have, because we're a B Corp, we invest $500,000 a year in research projects.
Wow.
So typically, and you have to put in an application, explain why it will improve the quality of design in the world, et cetera. Because our mission, Dialogue's mission, is through great design to improve the quality, or to improve the well-being of our communities and the environment they're part of. So as long as it's consistent with that. So it's not totally running wild. But I love prototypes because it allows you to leap out 20, 30 years ahead. You're not constrained by, well, the market's not doing this right now. We can't do this. So instead, what you can do is you can create a prototype that then maybe gets the market thinking. And there's the building behind me here on the picture is the example of one of the first prototypes I worked on. It's called the 105-story hybrid mass timber tower. And I, about 5 or 6 years ago, started to get a little frustrated with the whole discussion about mass timber, because there was this discussion of purity, of, is it all mass timber? How tall can you build an all mass timber building? And I went, whoa, wait a minute here. Like, what do you mean all mass timber? You have a concrete foundation, so it's not all mass timber. And what holds those pieces together? It's not wood dowels, it's steel. So it's not all mass timber. It sounded very religious almost. And I have a slide in one of my presentation decks that says, mass timber is a building material, not a religion. And so I said, the point of mass timber is to get as much carbon stored and as low embodied carbon as possible for a building. So I said to my engineers, I got a group of engineers and architects together, and I said, how can we design a super tall building? Because if it's not super tall, no one in the world is going to pay attention. But a super tall building is a building defined as above 100 stories. So how do we do a building above 100 stories that uses mass timber? So as we researched and came up with different models for doing this, all of a sudden we discovered that 60 to 70% of the building mass is in the floor systems. Well, the floor systems play a very small role in the overall vertical structure. So what we did was we said, let's have a very typical steel exterior skeleton of a super tall and a concrete core, typical, but the floor system will be cross-laminated mass timber. And all of a sudden you have a 105-story tower with mass timber. And that is the ability to use mass timber in a tall building, because I wanted to demonstrate to people, folks, we don't have to have this pure only mass timber. We can do 12 stories. Now we can do 18. Yay. Well, really, even though I firmly believe that probably the future of cities is 7 stories, nevertheless, people are still building tall buildings. And if we're going to build tall buildings, how do we use mass timber in them? So now here's what's happened as a result. We partnered with one of Canada's largest, most sophisticated construction companies, Ellis Don. And they have, they're all really bright engineers, the people we're working with. And they teamed up with us to figure out how much it would cost and how you'd actually build it. So to the wonderful engineers that work with our team was Mark Gaglione and Vincent Davenport. And so they were the ones that actually, we created a hybrid floor system that had steel and concrete in it to give it the length of span for a tall building. And they were the ones that, with us, made it reality. And we've just finished, last year, testing a 40-foot span, 20 by 40-foot span. And usually mass timber only is 30 feet. So this is a long span. It met all the requirements for bending and creep and all that stuff and shear. And then we burned it to prove that it withstood the actual burn. So what that went from an idea into the most sophisticated, most respected construction company in Canada saying, we did it. And not just an architect and engineer saying, we theoretically think it's possible. We built it and showed it. So now we're talking to clients about using the floor panel in buildings. They don't have to be 105 stories. And what happened is I got a call one day from the magazine Fast Company. They said, hi, we just want to let you know that you're the winner of the 2021 most innovative concept or design idea. Really? We didn't even know we were nominated. So, I mean, it goes to show you that a little idea can actually become like the starfish. It can make a difference. That one idea of a few engineers and architects talking about how to do it could actually have an impact on our profession. So I think that's the power of a prototype, is to take an idea and build it out and imagine what it would be like. Because most people that aren't architects and designers can't imagine what things will look like or feel like or be like. But if you prototype it, then all of a sudden they have a sense of it, a real tactile sense of what they're dealing with. And that's the power of prototype. And just to extend a little further, the prototype I'm working on right now is a prototype for a zero carbon, climate adapted multi-unit residential building that understands what the impacts, it looks at the impacts of climate change and says, what will we need to do to design, engineer a building that can withstand all those impacts?
And you have to do it. You have to do the work to even imagine it. You have to do the work. I mean, you have to sketch it,
you draw it and engineer it and figure it out and test it.
And collaborate with anybody that's
and collaborate not just with dialogue folks, but go outside and work with a constructor. We work with National Research Council for testing. So it becomes this much bigger discourse than just what architects and engineers are talking about in their shop.
All right. So we have so many questions that we're not going to get to, but
we're going to run out of time, Linda.
I know. So there's a couple of things that have come up that I do want to make sure we talk about, and we just struck on one of them: collaborative design. So you've got this Indigenous knowledge and collaborative approaches angle going on in some projects. Talk to us a little bit about that.
Okay, well, let's split the two apart.
Okay.
With respect to Indigenous design, in Canada, there has been significant discussion over the last 10 years about reconciliation with Indigenous peoples. And part of that is how we will design and engineer buildings. So typically now on our public projects, like for me, most of my work is public projects at universities and colleges. We will team up with an Indigenous architect designer and work together on the project. Nothing about us without us. So I wouldn't hold forth on what Indigenous design is. I have a really good sense of what Indigenous design is, but I'm going to have that conversation with the client with one of my friends who is an Indigenous designer and talk about it, because he or she, and I have a number of folks that we work with, will be able to talk to it. I mean, from the heart. I mean, from their own personal experience and from their lived experience and their cultural experience. And what I thought was really fascinating was in a project we completed some time ago. It's just getting lots of awards because it's really striking project. The Centennial College educational classroom facility. It was done in collaboration with Smoke Architecture. And we had a concept that we talked about called two-eyed seeing. And two-eyed seeing is a Mi'kmaq, which is an Indigenous community in the Maritimes in Nova Scotia and New Brunswick, that has this concept of two-eyed seeing being a Western lens and an Indigenous lens together make for a better understanding of what the world could be. And so for us, design, when you're doing public buildings and there's an Indigenous community in any way connected, because Centennial had an Indigenous student population that we're going to be using the building, you have to have both lenses. And by the way, it's not like being shackled. It actually creates many new kinds of insights that you might not have ever had before.
Yeah, and wonder on both sides.
Absolutely. Like one of the really fun things that we came up with was, how do we clad this building? It's a big building in a way that's cost effective, resilient, but also reflective of organic types of design. And so we said, well, what about if we use the design of fish scales? So the building cladding is painted aluminum white panels that overlap one another like shingles, but they have a shape of a trout scale. And they're beautiful. And you just look at it and it feels organic. It's not organic. It's like aluminum, but it has this feeling of like something that's alive. So, and others, many others examples we don't have time to talk about. But for me, collaboration with Indigenous partners is really exciting because we're bringing both sort of cultural lenses to bear on a challenge, which makes for a much more dynamic design process.
Yeah. All the conversations about diversity in business and the emphasis on like, how come we have to me, I always think, how come we have to drag people into this notion that diversity is good? Of course it's good. Like you can't possibly have thought of everything yourself, and neither your tribe, but when you just bring people from different angles, they see things differently, and you come up with something that's like 1 and 1 equals 11.
Yes, I agree.
Not 1 and 1 make 2.
And sometimes, I mean, I always think that I have to be careful not to assume that what I think is good and I like, other people will. And I think one of the challenges in architecture and engineering is the difference between introverted and extroverted designers and engineers. Architects, my experience has been, and I don't want to generalize, but introverted architects are people that have a vision of what they think makes the most sense. And they're not that interested, and they're not comfortable in growing ideas through collaboration. I'm a very extroverted architect. I don't like to design unless I'm designing in collaboration. I like to say, what about this idea? And some goes, well, you could do this. Oh, but we could do this. But what about this? And then you sketch and doodle. And then I don't want to say that's my idea, because it's like the idea is growing. Like you said, 1 + 1 = 11. Oh, for sure. The idea is literally growing in front of you. I find that super exciting and lots of fun. So, but I'm a sort of extroverted person. But I know designers that are really talented and they do great work, but they're lone wolves. And so I think one of the challenges is that we have to sort of understand where people are coming from and try and work that introverted, extroverted so that it works in a team. And I'll tell you, if you're doing a meeting, extroverts always like to talk, put their hands up and talk. Make sure that if you're doing public consultation, that you have written forms, like you have sticky notes where people that don't like to talk can do a sticky note and post it. So there are ways to collaborate for introverts. And I think that's the beauty of having a good collaboration methodology is introverts and extroverts can come together and not feel like, either is being in any way encumbered.
And, that brings me to this whole concept, because you're sort of collaborating with time. You're collaborating with people of 20 generations ago when you think of your concept called the 1,000-year building. Okay, because that's the ultimate collaboration, is to collaborate with people that were doing something very cool 1,000 years ago. I mean, and they're not here to represent themselves, but their work does. And it is, still sitting there useful. So talk to us before we wrap up about this 1,000-year building concept.
So this was another prototype. We haven't started it yet, but it's been a thought experiment. And we started to talk about climate change and climate impacts. And I've always found that unless you have a compelling idea, that the idea itself gets over the hurdle of, I don't want to talk about climate change again. Oh, it's so dark and depressing, and just stop. But if you have an idea itself that's intriguing and interesting, you can somehow get past or bypass the whole negative vibe of climate change. So I don't like to talk about climate change because it just is puts people off, right? So we're thinking, okay, one of the challenges of climate change impacts is going to be our buildings are going to get really beaten up by storms and flooding. Okay, so what would we have to do in order to design a building that would last 100 years? Because right now our buildings aren't designed to last 100 years, even in normal conditions. What do we have to do? And I said, no. Just like the 105-story tower, if we designed a 35-story tower, no one would talk to us. Who cares? Like, whatever. But 105, people poke up their heads. So I said, instead of 100, what if we said 1,000? Because think of the longest buildings you can think of, like the pyramids and the Pantheon. They're like 1,000 years old. And people remember them. So if you say, we're going to design a 1,000-year building, we're like, whoa, that's interesting. And then you start to say, well, time, that things are going to happen over that time. What do you have to do? So in a nutshell, here's the two things we've arrived at. And it comes out of exploring historical buildings too. One is you design for durability of the basic structure. So stone, if you're using concrete, it's got to be a concrete like the Pusillanimo concrete from Rome that lasts forever, or brick. And then that lasts almost forever. And then you have pieces of the building that don't last forever, but can be easily replaced, like wood windows. Local, not expensive, not complicated. You don't have to be, a PhD to figure out how to do the wall section, or an engineer. You can just be a carpenter or a handyman. And so the building goes on in its basic form, but the sort of accretions over time, and make sure that the building has a lot of room for different things in it. Like, it's very generic. Like, that's why factories are so popular. Old factories now in industrialized U.S. cities and Canadian cities, they're the coolest places for apartments. Why? Because you got huge apartments and there's wood, all the wood beams. They're just so cool. Well, guess what? They were like built as factories, but now they can be used as apartments. They can be used as retail. They can be used as anything. So build big generic spaces that can be used for all sorts of things. And the other thing to do is the structure, the stone, the brick or whatever on the outside stays there. But on the inside, what about mass timber that is modular in the sense that you can take it apart? And I know from doing construction of mass timber, there are connections that you can take apart and reassemble. So reassemble the building inside. So a 1,000-year building isn't just because it lasts that long, but because it can be evolved in its function over time, and understand that, and not be like, oh, it's just right now we design our residential buildings to be like 9 feet ceilings. Like you can't put anything else in there ever, right? So, but again, there's no economy for this. Like no one wants a lineup for this. So that is we can get into another long podcast about financing 1,000-year buildings. There are people that actually want to do 1,000-year bonds, believe it or not. But anyway, that's another story.
And it does come down to money, don't you think? I mean, all the dreaming, you got to have the money partners to dream big with too, because that's kind of where the rubber meets the road, right? Is that
you've got to have it. You've got to have a market that wants it. You've got to have demand for it. You've got to have people willing to invest in it. Yes, it's got to be part of a financial logic that means it's going to happen. But I think when we're doing our prototypes, it's not pie in the sky. It's understanding that things will change. And all of a sudden, things that weren't cost effective before, it's like, well, wait a minute. Maybe if we do it this way, we'll get insurance. Whereas before, you wouldn't.
Okay.
If you can't insure a building, you can't even build it, right? So if you can demonstrate the insurance company that you can beat this building up, it doesn't matter. It's not going to take away one cent of its value. Wow. We're willing to pay for that.
Yes.
So I think you're absolutely right. The financial logic has to be there. This is not like, oh, this would be nice if we could do this. It would be morally responsible. No. Let's look at the financial logic behind these things. The idea of a 1,000-year building is sort of a gesture to say, these are the kind of things to think about. But you can bring it back to today's reality by saying, well, how are we going to adapt to these really? And by the way, it won't happen till a storm rips through one of the big cities in North America and trashes every piece of glass. Then people will go, oh dear, what do we do?
And this resiliency that you're talking about buildings, anybody who's traveled knows you go and visit the Alhambra in Spain or whatever, like you name it, you go and visit really, really old buildings. And the tour is all about, and then the Dominici family added this, and then somebody else changed all these things. Right. And that
they were works in progress forever.
And that was the original building, or the archaeology in England. If you watch any of those shows about the archaeology of England, Digging for Britain, I'll recommend people. I fall asleep to Digging to Britain almost every night. Digging for Britain. What you learn is that there is a way to do good work that serves humanity over and over and over again throughout human innovation, throughout humanity's iterations, because we do reinvent ourselves and what we care about over and over again.
Yeah, and I think the challenge we faced in the last 100 years, since modernism really was launched in the late 19th century with cast iron and then steel and then concrete after the war. Architects like Corbusier loved the German gun emplacements on Normandy and thought that would just make wonderful buildings.
Right. Yeah. Then there's
that's really. And so I think the modernists have a lot to answer for. But the idea was, in all fairness, they were looking for figuring out how to free up people from what they thought were slums and tenements and give them light. And that was like putting buildings in parks, big, tall buildings. But the problem is, they didn't think it through entirely. And all of those tenements, well, there are better ways to fix them than just to bulldoze them. And so I think we have to rethink how we make cities. And by the way, I want to leave your listeners with some ideas. I talked about electrification as being a really, really important thing. Density is also a really important thing. I think people say cities bad, dense, pollution. Well, they say, well, most pollution comes from cities. It is true because you have the greatest population. But here's the really interesting thing. Dense cities have about a third of the carbon dioxide emissions of suburbs.
Really?
Yes. Because think about it. You live in an apartment or a townhouse, and what do? You walk to get your groceries. I walk. I live in the city. I walk to get my groceries. I walk over to the subway to go to work. I go to a park, walk there. So I don't use the car much. So think about all that transportation, CO2 gone. Then the other thing to think about is like in the suburbs, you have to drive to get milk, you drive to get coffee, drive to get your kids at school, right? These kids don't walk home from school. Then add another thing, embodied carbon. Like if you look at how many feet of pipe, copper pipe for water, sewer pipe, water pipe, all that stuff, right? That is longer per person in the suburbs. Like it goes hundreds of feet per person, whereas in the city, it's like tens of feet. So all of that is reduced. All of that's tighter. It costs less per person. Everything's less to service, and there's much less in emissions. So density is a really important tool to reduce carbon. Density is also probably a challenge when we look at flooding, but you can still design cities to be very effective when they're dealing with water. It's just a question of design.
And aren't we there? I mean, like I in my life, I've traveled so much that now I can go to places and look sideways and know that Venice isn't the only city that's right all the way almost on its knees from rising water. You can see a lot.
Boston is.
Yes.
Well, I went down for a reunion in Boston, and they had a climate resilience conference going on, and they said that they just missed a high tide, a spring tide, and storm that would have flooded all of Boston. Like it's that close. Miami's flooding now. It's already started. So, I mean, coastal cities. I mean, we've been doing some work with clients on climate adaptation, and coastal cities are in big trouble if they're at sea level.
Well, and then there's the whole infrastructure underwater. Like,
yes,
heck, it was at least I have a daughter who's an engineer, and she's very, very interested in innovation and so forth. And she was studying what's happening with Miami's
aquifer
sewer. Their sewer system.
Yeah.
10 years ago needed replacement because it's only like 7 feet above sea level. That's got to be different.
Well, now it's not. Now it's under.
Right.
Yeah.
And it was going to cost like $4 billion
right.
to replace it, but there's not that many places that is high water. Like,
yeah.
I mean, it's all these things.
No, it's all these things, right? And so I think we're going to have some really serious discussions about how we will design, engineer, and build in the future. The challenge is how to have conversations without them becoming acrimonious. And I think that's another podcast, and there's probably other guests that are much better to talk about it than I am. But I think, good news is only good news when it reaches ears that can do something with it and believe it, right?
Yeah. And belief is, interestingly, I interviewed Craig's wife, who's also going to be a podcast guest. And that's actually what we were talking about is belief in each other. Her organization is giving scholarships to kids that just need somebody to believe in them, that they have great ideas and great.
And what huge impact it has.
Yeah.
It's amazing.
Yeah. So I think you probably, as we wrap up here, like there's a concept right there. Like, is there something you really wish we knew? Like sometimes, if you look in the news or you just look at the state of urban planning now or whatever, what do you really wish people knew, Craig?
Well, I wish they knew how serious that the challenges we face of climate change, and how we are going to have to not only take climate change and mitigation seriously, but take adaptation seriously. How to start thinking about adaptation as a reality, not as a scare tactic that unless we do this, this will happen. It's like, no. These kind of impacts are going to be increasing. What do we do as communities to adapt? Humans are very, very adaptive creatures. They're very adaptive. There's a lot of things we can do, and I think we have to come together as communities to figure out the best. And there's no right answer for anyone, for all communities. Each one has its own challenges, but they have to come together and acknowledge that there's going to be these challenges and think, here are some of the things we can do as a community. For example, sea level rise. There are a number of things you can do to adapt. You can adapt to the sea level rise, like have building on stilts, because you're going to say over the years, you know what, it will go up and down, up and down. For the next 25 years, we can deal with that. Or you can say, we're going to move out, like we're going to relocate those buildings out of town. Or what they're doing in some areas in California is the government is having bonds to buy all the buildings right on the coast, like the beautiful, expensive houses, but they're going to go down in like 20 years. But they buy them and then they rent them out for that period of time, and the rent pays off the mortgage so that it hasn't cost anyone any money. The people get their money out and they can stay renting if they want. But they haven't lost the value of those houses. Like it's been lost, but it's been made up for by the servicing of the debt via the rent. And so there's like, we have to like not use this as a he said, she said, you're bad, you're good. And instead say, okay, no, how are we going to work together to figure this problem out? Because, by the way, I do not think that there are big villains in this. I know everyone wants to attack fossil fuel, but fossil fuels have done a lot of positive things for humanity. And no one set out saying, we're going to have fossil fuel and we're not telling anyone it's going to choke our atmosphere and we're going to have, no, I mean, it sort of became evident. And once it became evident, it was all locked in and people had jobs and stuff. You don't just say abandon ship. So I think we have to say, okay, but now is the time to transition. And we can transition and we can do it economically. We can have a green boom. I know that that's not believed in some quarters, but there's lots of things we can do to decrease the carbon we produce through electrification and then adapt to what we're facing. And it's not going to be easy, but we're very, very creative creatures.
And I think that you're bringing something to the table in just the short time we had to discuss this, that there will be gains. Like it won't all feel like a loss.
No.
Right?
No,
like
I agree.
So if you have to go to more timber, we're going to feel more lovely in our environment. Yep. So it won't be all giving up something. We'll be getting things that we can't even imagine right now.
I think that's one of the beautiful things about the book by Ezra Klein and Derek Thompson, Abundance, is this notion from the 70s of having to give up, as opposed to actually we could build more that would be good for the environment and good for us if we did it right. And it would produce lots of jobs and it would stir the economy. And so it's like, well, wait a minute, why aren't we doing this? Because we've got this mindset of, in order to do right, we have to do less. Well, guess what? If you tell people that, they're just going to say, we're not doing that. But if you say, actually, if we do this, we'll get more and it will be better and it will be greener. There's a lot of people in the environmental movement that hate that. They just are totally against it. But I don't think so. I think there's some real possible.
Well, I think, the best ideas in this world, what I've noticed about innovators, some of the best innovators, there's those that survive the pushback stage and they just keep going until what they're proposing seems absolutely obvious. Yeah. And then there are those who come up with an idea so ingenious that hardly anybody can push back on it. It just seems like that obvious thing that no one was seeing that was right there in front of our nose. And I think that you've impressed me as that you're working in both ethoses. And, I just got to tell you, Craig, I can't thank you enough.
Oh, it's been such my pleasure and such a lot of fun. Yeah.
I mean, this is huge. These are the very structures and the future of what our kids, how they'll live, and everything around us is about urban design and architecture. And I think that anybody who listens to this podcast will understand it in a whole new way now. So
I'm going to do two things right now before this podcast ends. One is I'm going to thank you for doing your podcast, and I'm going to invite you to be on my podcast. I'm usually on the other side. I'm usually on your side of the mic, because I host a podcast called the 21st Century Imperative podcast. Okay. And the imperative is we have to do this or else, right?
Yeah.
And I interview people that are making a difference, can inspire people to believe that they can do something positive. Because so much of this discourse is so negative that I get young people, middle-aged people, whatever, people that have done things in their lives that say, we can make a positive difference, so that we give an example, as opposed to saying, you should do this, you should do that. It sort of gives real life examples of people that have made difference. So thank you very much. And your podcast is really important.
Well, and I will be delighted to be a guest.
Thank you, Linda.
I don't know. This is the way we're going to get forward. At the 2 steps forward, 1 step backward world. Maybe we're doing the 1 step backward right now, but the way we go forward is to band together, to be multipliers for each other. And like I always say, that 1 + 1 = 11.
11. I like
sometimes.
That's a good one.
All right. Have a great, great day, Craig.
Thanks, Linda.
Thank you so much.
Cheers.